All right, so get this. Ready for like a fascinating fact. Climate change is making our days on Earth longer.
No way, really?
Yeah. No, now before you go adjusting your schedule, I'm talking like milliseconds here, so tiny, but significant.
Wow.
And today we're going to do a deep dive into some cutting-edge NASA research to understand how climate change is like subtly impacting Earth's very rotation.
It really highlights how interconnected our planet is. Even small changes can cascade into big effects across the globe.
Exactly, yeah. So let's start with this whole concept of polar motion.
Okay.
It sounds kind of complex, right?
Yeah, it's simpler than you might think.
Okay.
Imagine Earth is spinning like a top, right? But that top is slightly off balance.
Uh-huh.
It wobbles a bit as it spins, and that's essentially what's happening with Earth's rotation.
Okay.
The axis that it spins on isn't fixed. It actually moves around a bit.
A 30-foot shift over the last 120 years. That's like the length of a school bus.
It's a big...
That's not so tiny when you put it that way.
Right.
So how in the world do scientists even measure that kind of movement?
Oh, scientists have come a long way.
Yeah.
They used to track this wobble by observing the movement of stars.
Wow.
Can you believe that? And now they bounce lasers off satellites to get incredibly precise measurements.
Wow, that's a serious upgrade. So what is causing this wobble in the first place? What's going on?
Well, it all comes down to the distribution of mass on Earth.
Okay.
Think of it like shifting weight around on that spinning top we talked about.
Okay.
When massive things like glaciers and ice sheets melt, all that water flows into the oceans, and it just changes the weight distribution, impacting the way the Earth wobbles.
So it's not just the melting ice, but rising sea levels are playing a role too.
Absolutely. As that meltwater adds to the oceans and as the water itself expands as it gets warmer, it shifts even more weight around.
Right.
It's a chain reaction with a global impact.
Yeah. It sounds like a massive puzzle to put all this together.
It is.
How did scientists even pinpoint this connection between climate change and the Earth's wobble?
Well, they use some pretty incredible technology, right? They fed 120 years of data on Earth's wobble into a machine learning program.
Wow.
And what they found is that a staggering 90% of this wobble is directly linked to these mass shifts, so melting ice, changes in groundwater, and rising sea levels.
So we're literally throwing the planet off balance.
Yeah.
That's pretty sobering.
It is. And while these mass shifts have always happened naturally, the rate of change is speeding up because of human-caused climate change.
All right.
We're accelerating these processes.
Okay, I'm starting to see the bigger picture here. We've got melting ice, we've got shifting mass, we got a wobbling Earth.
Yeah.
But how does this all connect to like the length of our days getting longer?
This is where it gets really fascinating, okay? Think of an ice skater spinning. When they pull their arms in, they spin faster, right?
Right.
Same principle applies to Earth. So when mass shifts towards the equator, like when ice melts and flows into the oceans, it's like the Earth is pulling its arms in, slowing down the rotation ever so slightly.
So all that melting ice is acting like a brake on the Earth's rotation.
Kind of, yeah.
And those NASA missions, Grace and Graceful, they're helping us measure this with incredible precision, right?
Exactly. Grace and Graceful, they're like a giant scale in space, constantly measuring Earth's gravity field.
Wow.
So as that ice melts and water shifts around, they can detect even the tiniest variations in gravity.
Wow.
It's an incredible tool for understanding these complex processes.
But just how much longer are our days getting? Are we talking like noticeable changes already?
Well, not so much that you'd need to adjust your clock just yet.
Right.
Since the year 2000, days have been lengthening at a rate of about 1.33 milliseconds per century.
1.33 milliseconds. That doesn't seem like much at all.
You're right. On a human timescale, it's a tiny change. Yeah.
But think about this.
Okay.
That rate is faster than any time in the previous 100 years.
Wow.
It might seem subtle, but it's a clear indication that climate change is impacting even the most fundamental aspects of our planet.
So are we just going to keep spinning slower and slower as more ice melts? Like, what does the future hold for Earth's rotation?
That's the big question, and it's one we'll delve into next time.
Yeah.
We'll explore some of the different scenarios scientists are projecting for Earth's rotation, depending on how we handle this whole climate change challenge.
Okay, well, I can't wait.
Stay tuned.
I can't wait, yeah. So we're back, and I am still wrapping my head around the fact that melting ice is actually slowing down Earth's rotation.
It's pretty wild, isn't it?
It is wild.
It really speaks to the interconnectedness of everything on Earth.
Yeah.
And it's incredible how scientists can even measure these subtle changes with such precision.
Yeah.
Those graceful missions.
They're like having a planetary checkup, constantly monitoring the Earth's vital signs.
Speaking of grace, you mentioned these satellites are like a giant scale in space.
Yeah.
How do they actually measure those tiny variations in gravity caused by like the melting ice in the shifting water?
Well, imagine two identical satellites chasing each other in orbit,
Yeah.
separated by about 130 miles.
Okay.
They're constantly sending microwave signals back and forth,
Oh,
measuring the distance between them with incredible accuracy.
wow.
As they pass over areas with different mass concentrations, like a massive ice sheet or a growing reservoir,
Uh-huh.
the gravitational pull on each satellite changes slightly, altering that distance.
So if one satellite flies over a region with more mass,
Yeah.
it gets pulled slightly ahead of the other,
Yeah.
and Grace can detect that tiny difference in distance.
Exactly. And by analyzing those minute changes in distance,
Wow.
scientists can map out the Earth's gravity field in incredible detail. It's like having a 3D map of where mass is concentrated and how it's moving around the planet.
That's amazing.
It is.
So we've got this amazing technology giving us detailed data on mass shifts.
Yeah.
But how do scientists use that data to understand what's happening with Earth's rotation?
That's where sophisticated computer models come in.
Okay.
These models combine the gray seed data with our understanding of physics and the Earth's interior structure.
Right.
Scientists can then run simulations to see how different mass shifts would impact the Earth's spin.
So it's like they're creating a virtual Earth inside a computer
Yeah,
and then experimenting with different scenarios. That's fascinating.
it is. It is.
Yeah.
And by comparing those simulations to the actual observed changes in Earth's rotation, they can validate their findings and learn more about the complex forces at play.
Okay.
They can even isolate the effects of specific factors, like melting ice versus changes in groundwater,
Right.
to see how each one contributes to the overall change in rotation.
This is all starting to make sense now, but it also raises some important questions about the future.
Yeah.
I mean, what are the long-term implications of these changes in Earth's rotation?
Right.
Should we be worried about days getting so long that we need to adjust our calendars?
That's a great question. And the answer is complex
Okay.
on a human timescale.
Yeah.
The changes are so gradual
Right.
that we don't need to worry about needing extra hours in our day anytime soon.
Okay, good.
However,
Yeah.
these changes can have more subtle but significant impacts.
Okay, like what kinds of impacts are we talking about?
Even slight variations in Earth's rotation can affect the accuracy of GPS systems.
Really?
Think about it. Those systems rely on incredibly precise timing signals.
Right.
Even a tiny wobble can throw those calculations off.
Wow.
It can also have implications for the timing of tides and ocean currents,
Okay.
which are crucial for marine ecosystems and coastal communities.
Wow. So it's not just about the length of a day, but it's about like these cascading effects that those changes trigger
Totally.
in other parts of the Earth system, right?
Yeah.
And I'm guessing those milliseconds are telling a story that goes far beyond just the ticking of a clock.
You got it. And that story's still unfolding.
Hmm.
What we do in the coming decades will determine how that story continues to be written.
It's a powerful thought,
Hmm.
It's a reminder that we're not just passive observers of these changes.
Right.
We have a role to play in shaping the future of our planet.
Absolutely.
Speaking of the future, you mentioned that scientists are projecting different scenarios for Earth's rotation, depending on how we handle climate change.
Yeah.
Can you tell us more about those scenarios?
Absolutely. That's a discussion that deserves its own deep dive.
Okay.
We'll explore those different pathways and what they mean for our planet's rotation later on.
Okay, sounds good. Okay, so we're back and ready to unpack those future scenarios for Earth's rotation. You mentioned there were different projections, right, depending on how we handle climate change.
That's right. Yeah, the future of Earth's rotation is very much in our hands, just like the climate itself,
Right, yeah.
The choices we make regarding greenhouse gas emissions will directly impact how much ice melts, how mass shifts around the planet, and ultimately how fast our days continue to lengthen.
Okay, so let's walk through some of those scenarios.
Okay.
Let's start with the best case scenario.
Okay.
What happens if we manage to, drastically reduce our emissions and really tackle climate change head on?
Well, even in that best case scenario where we achieve significant emission reductions, The lengthening of days is likely to continue.
Oh, really?
The climate system has a lot of inertia.
Right.
The greenhouse gases we've already emitted will continue to have an impact for decades to come.
So even with our best efforts, we're still going to see some, like, lingering effects.
That's right. However, the rate of change would likely slow down. Scientists estimate that under a low-emission scenario, the lengthening of days due to ice and groundwater changes could decelerate by the year 2100.
Hmm.
It's a sign that our actions can make a difference, even if there's a time lag in the response.
Okay, well, that's a glimmer of hope, at least.
Yeah.
But what about the flip side?
Right.
What happens if we stay on our current trajectory and emissions continue to rise?
That's where things get more concerning.
Okay.
If we continue on a high-emission pathway, the models suggest that the lengthening of days could accelerate significantly.
Oh.
In fact, it could reach a point where it outpaces the effect of the moon's pull on tides.
Wait, climate change could have a bigger impact on Earth's rotation than the moon.
It's crazy.
That's incredible.
It really puts things into perspective, doesn't it?
Yeah.
The moon's gravitational pull creates tides in our oceans, and this tidal friction has been gradually slowing down Earth's rotation for billions of years.
Right.
It's the reason why days have been getting longer over geological time.
Right.
On average, this lunar effect increases the length of a day by about 2.4 milliseconds per century.
So you're saying that, like, under a high emission scenario, climate change could, like, push that rate even higher?
Exactly. The models suggest that with continued high emissions, the lengthening of days due to climate change could reach as high as 2.62 milliseconds per century.
Wow.
That's faster than the moon's current influence.
Yeah.
It's a stark reminder that we're becoming a force of nature on par with some of the most powerful forces in the cosmos.
It's both humbling and a little terrifying.
I know, it's heavy.
We're talking about altering the very rhythm of our planet.
Yeah, it is a lot to process, but I think it's important to remember that we still have the power to choose a different path.
Right.
The future is not set in stone.
Right.
The actions we take today can shape the trajectory of Earth's rotation and the future of our planet.
That's a good point. That's a good point. It's a powerful reminder that, we're not just along for the ride. We're at the wheel.
We are.
And to our listeners out there,
Yeah.
as you go about your day, think about those subtle yet profound ways in which our actions are impacting, like the very spin of our planet.
Yeah.
It's a humbling reminder that we're all part of something much bigger than ourselves.
We are.
That's really neat, I think.
It is. It is.
That wraps it up for today's deep dive into how climate change is affecting the Earth's rotation.
Right.
It's mind-boggling to think about the interconnectedness of everything on our planet and the impact our actions have, on a global scale.
Absolutely.
Thanks for joining us on this journey, and we'll see you next time for another fascinating deep dive into the forces shaping our world.